Hi, and welcome to our fourth and final little hands-on with getting familiar with the Arduino platform. So in the last video, we talked about the Arduino, and we talked about kind of the power going in, the digital pins. This time, we're actually going to look at the analog pins down here. And what we're going to do is that, unlike last time, where our hello world was to kind of have an output from the board is going to help us this time by pulling in an input. And how we're going to do that is that we are going to use a photocell, which is probably really hard for you to see. Let me kind of get that paper out again. A little photocell here. And what this does is that it measures relative brightness of light. And to do that, we are going to use jumper cables again, our Arduino board or breadboard. This time I have an extra jumper cable. I have a yellow one in addition to our red and black. It doesn't matter what color. What we're going to do is we're actually going to be using this one to read, and then black and red as our power sources. And we're also going to use a resistor. This time it's going to be a 10K ohm. The colors are brown, black, orange for 10K, and then depending on your tolerance, usually I think the last color is gold, as I think it's 10%. I might be wrong, but it doesn't really matter. The most important ones are brown, black, and orange. So just to talk about how the photocell works, just to help us understand how sensing works, is that, of course, this is an electronics piece, and it has two legs. Unlike our LED, it's not polarized, so we can stick it in either way. But basically, this photocell works as a resistor. And how that works is that it'll be really hard for you to see, but if you look at the top of the photocell, you'll see that there is kind of a metal surface and then this ceramic bottom underneath it, so a little metal top, ceramic bottom, and some type of pattern. And how this works is that it basically, as I said, works as a resistor, and the properties of the metal with the ceramics is that as light, photons from light touch the top of the photocell, it actually changes the resistance of the photocell. So when we kind of send voltage in or send a current in, based on how much light, this will actually provide a different amount of resistance. So what's coming out at the end will actually be different. We can measure that in just very simplistic terms. So yeah, because of the chemical properties of the top, it's responding to the light that's around us, and therefore we can measure kind of how that circuit changes. I'll say too that what we have is fairly basic. There are sensors out there that are much more precise, and really what we're doing with this is that we're measuring relative brightness. We're not measuring exact. It's very hard. So right now I'll actually put up on the screen an output from the technical sheet where we can actually understand how this photocell will actually tell us something about the illuminance. So you can see how the resistance drops with increased brightness. Again, seeing this, it's on a log scale. We can't easily read precise levels with this, just because of how cheap our photocell is. There are more precise instruments out there to do that for us. But you can see that this at least gives us a sense of how bright a space is, at least in kind of coarse terms. So this might be useful for, a light that turns on when it's dark, so a night light type of thing. And how we're going to use this is with our Arduino board. We're just going to get a very basic categorical semi-qualitative measurement of brightness. So we're going to first set up our board, and then we'll go into the platform, the IDE, to write our code. So we're going to start by putting in our photocell. So in this case, I am going to, again, start at the top and use row 3 and row 5 just because that's the rough length of our legs. So I'll stick that in. And I'll already start by connecting power to one of those legs. So that will be, in this case, much like we did with hands on 3, it was to kind of row 5. Sorry, row 3. So again, my Arduino, you can see the light is off. There's no power going in, so I can do this safely while testing things out. Unlike last time where we were controlling the LED using our digital pin, this time we want the voltage to go in. Remember, because we're going to actually measure what happens on the other side. So we want the voltage going in. So we're going to, this time, connect it to our power pin 5 volts. So we're going to be sending in the maximum amount of volts through this circuit. But the difference this time is that, as I said, we have an additional cable this time that will help us read. What we're going to do is we're actually going to create kind of a parallel circuit. We're actually going to, instead of connecting ground to our photocell, we are going to read using our yellow pin. So we are going to put it, I'm going to put it in row 5, but I'm actually going to put it in the 4th slot. I'm going to put it right close, quite close to the photocell. Actually, I just need a little bit more space. I'll move over one. And then this is going to connect to analog 3. So with analog, we'll be able to read what's going on. And then our black, we are going to connect to ground, much like last time. But before that, we're actually going to stick in our resistor. So this is going to take a little creative jump. So I'm going to bend this again, connect it to row 5, where I have both the yellow pin and the second leg of the photocell. And again, I'm going to just kind of, because of the length of the legs, I'm going to just go further down the board. So basically, in that row, in our 5th row, we have the second leg of the photocell. We have the yellow pin, which is our read. And we have the first leg for the resistor. And let me kind of bring it closer. I don't know if you'll be able to see it clearly with the camera set up. But you can kind of see how they're all in the row. And then in the 3rd row, I have our power in going into that first leg of the photocell. And now we need to complete it to make it kind of go to ground. So I have my black cable. Although, because of how I stacked it, kind of moving, I guess to you maybe to the left for me, it's actually to the right. Everything's upside down here. Because, we've stacked it all in a row. I'm actually going to, again, because the horizontals are all interconnected, it doesn't matter where I stick it, as long as it's in the same row. I'm going to do that here. I'm going to stick it in the same row as our photocell, of our resistor. So the leg, same row, black, and I'm going to send this to ground. So our circuit should be complete. So now let's move to the coding environment before we plug everything in. So because we're reading this time, it does kind of become important for us to open our serial port. So much like we've done before, we're going to first start in setup. Actually, much like last time, just to catch us up, depending on what platform you're working in, whether you're in the cloud or on the desktop IDE, I'll just make a code so that we can kind of go back. All right, and now we're going to go into our void setup. So we're going to set up our serial port, 96 BPS, or kbps 9600, much like we've done many other times. But I'm also going to have it print out so that we know that we've finished void setup, again, to help us debug in the case that anything goes wrong. And if there's other previous output in the serial monitor, we'll be able to know when things should be working, when everything's uploaded and ready to go for us. So print line, I'm going to say starting photocell. So when we run this code, when it's uploaded or when it's on the board and power goes in for the first time, it'll start the serial port, and it will tell us, it'll basically print that we started the photocell. Okay, great. Now we are going to go into our void loop. So we're going to create an integer. So this is something that's saved in memory. So every time this loop runs, it will create and save just for the duration of the loop this value. So we're going to create an integer, so we have to declare it directly. This is a difference between Python and Java. In Java languages, you have to declare what type of data type it is. So here we say directly it's an integer, and a log value. So that's our variable name, analog value. You could call this X or Y or whatever too, but I'm just kind of being a little bit more complete so that we know what we're looking at. Analog read A3. So analog read, what it does is that it will read from pin A3. And then I will have it print out for us that value. So I will say first it'll say serial. So we're going to use serial print to just print out a line for us. And then it's going to say analog reading. And what it's going to do there is that it is going to just print that text for us. Notice that I use print and not print line. So what it's going to do is that instead of printing it in a new line, print ln, where it provides a line break, this is not going to provide a line break for us. This is just going to have that line. So then when I do the next thing, serial.print, oops, I don't want quotes, analog value, it's not going to autocomplete for me. So what's going to look like is it's going to print analog reading, colon, space, and then immediately after that, it's going to print analog value. And that value of analog value is from that command right above, that integer. Now, because we're working in the loop, the scope of this is going to remain in the loop. So if, for instance, we did a save, we could do that, but it's not saving it to memory. It only knows this while we're in the loop. So if you wanted to kind of declare scope outside of the loop for whatever reason, like you wanted this to go somewhere else, you may want to declare it outside of void loop. But because we're not really saving this, it's going to run, give us a value, show us, and then it's going to run it again. And we're basically just going to forget that number, that quantity. It's going to create a brand new variable that happens to be the same name and do it over again. So we're not actually saving anything into memory beyond the scope of this loop. So it's going to print that. But, as I said, things are relative. We're not going to be able to get the exact amount of lux, the amount of illuminance. So we are going to create something categorical, or we're going to show something categorical. So I'm going to write a little if statement to just tell us how bright the room is, or how bright whatever it's measuring it is, how much illuminance it has. So we're just going to use a categorical, dark, dim, bright, very bright. I don't know how bright it's going to be, but we'll see what it tells us. So again, I'm going to create that if statement. What was it? Analog value. If it's less than 10, it's going to do something for us. So I'm going to just send that down. So if it's less than 10, I want it to tell me print line, because if not, it'll just be kind of really squished in together. We could also do print. I might put in a space or something like that, but I'll just do print line just to keep things a little bit tidier. And I'll just say, tell us that it's dark. And I may want a space there. All right, but I don't, as I said, we'll have multiple categoricals. So, we'll actually need a little bit more. So what we're going to do is we are going to do else if analog value is less than 300, then we want it to print another thing for us. So we'll say serial.print line, and what do we call it? Say dim, I think our value was, semicolon, and then again, else if analog value, and of course you can just cut and copy this, but I'm just, 600. I'm just doing this kind of very quickly for our purposes here. Oops. Here's a secret if you're ever doing these tutorials. Live coding actually really sucks because you're trying to do too many things at one time. Oh, and I need to tell it to print serial print line. I think we said this was bright. And then else. So if it's anything else, we tell it to tell us serial print line very bright. I think that's right. Let's just do a kind of a quick check. See if this makes sense. See. Should be good. It looks about right. All right, well, we'll find out in a second, I guess. And then we wanted to just kind of, let's say, take a read every half a second. So delay 500 milliseconds. Let's make sure we have our semicolons. Looks about right. All right, so we're going to connect things and upload this code. So I'm going to connect my USB now. Power's going in. Let's see if it connects. Great. And then let's upload this code. And let's go to our serial monitor. You can see that in that code, in the first reading. Actually, let me change this. Let me do it every 1.5 seconds because this is moving way too quickly for me to talk. All right. So when we see that starting Photocell, that was our start. And now you can see that's taking a reading every 1.5 seconds. And let me cover up the Photocell. Still getting a lot of brightness in. But you can see some variation in how much the brightness is kind of changing. So as I said, yeah, there you go. You can see that now it's kind of getting darker. The reason is that it's coming from the side here. So now I'm kind of closing the side. Still very bright. Again, this is all relative. So what you could do is, and probably what I would do with this code is, seeing that my values are still very high, I would change the scale. I would just go in and change the numbers to a different scale. So you may want to start with a completely dark room. Let's see if so now I'm kind of closing the side up a little bit more with my hand. You can kind of see, trying to block the side light. Now it's kind of dim. I might even just reset that to be, the closest thing we have to kind of dark. Just because of the wiring, I can't really close my hands up anymore without kind of knocking things. But you can kind of see how the amount changes based on light. So I just moved my hand and now it's getting more light, probably reflecting off of the white of the breadboard. And then if I release my hand entirely, now it's just getting it ambient from all directions. So I'll also note, because this is measuring electricity, if you are going in and you're fidgeting with the wires so that the voltage kind of drops up and down, it will also change the values. So you do kind of want to keep it still or make sure that your circuit is pretty tight in. The best way to make sure that everything is tight is to solder. Our breadboard is really made for prototyping, but if you're doing a real circuit or real sensor out in the environment, you may want to consider soldering it. In our kit, we do have kind of breadboards to help us solder. But otherwise, here you have your prototype photo illuminance sensor. And we'll continue to play with it a little bit. Let's see how dark I can make it in our closing seconds of the video. So have fun with your photocell. Of course, we can plug this in with an LED, so maybe it serves as a nightlight. But there you go. You have your input. Hello, world. Enjoy.